Hello, ladies and gentlemen. My name is Paul Broderick. I hope you can all see the title screen entitled Bringing It All Together, Technology, Data and Digitisation. And thank you all for taking time off your daily work to join us here today. What we're going to be looking at is technology and data in construction. This slide shows the objectives of what this session is about. Hopefully it's going to be an interesting, non-technical and largely COVID-free session about the subject, which is the fast-moving and rapidly accelerating growth of technology in general, and looking a bit into the past, present, and then the future, because I think we can learn a lot today from the growth and the use of technology, and also have a look at how fast this technology is evolving. Construction in general is perceived as being well behind the curve in terms of adopting digitisation and digital transformation projects, despite there being a massive amount of technology available. So evidently, we're underutilising it. Construction is the queen of industries, including when compared to, say, manufacturing and finance, etc. We can qualitatively measure the health of our economy by the strength of the construction sector, which I think the recent COVID-19 epidemic has illustrated very, very clearly. There was somebody who once said, if you want to view the state of the country's economy, count the cranes in a cityscape. And I think that's still true today. So we're going to look at some of the things that are affecting how construction and digitisation and technology is being used. So here I am, who am I and what do I do? Well, I was educated at London University. I wrote my first computer program in 1970. It was on mainframe computers, because that's all there was then, paper tape, teletypes, punch cards. You've probably heard of them. There were no terminals or PCs in those days. I moved on to technical and business analysis after leaving university. We were in the infancy of IT then, both in industry and in business. We were learning and feeling our way into harnessing technology in businesses. So the technical and programming was mixed up and crossed over with business analysis, etc., which is very much more discreet these days and far more secure. You won't believe what confidential and sensitive information I had direct access to in my techie days. From the end user customer side of things, I jumped ship and moved on to the vendor side of things, where I've been working for 30 years or so within a wide range of businesses, often as part of larger teams, analysing business requirements, looking at returns on investment and capital investment requirements, and recommending to boards and committees solutions to improve their organisation through cost savings, profitability gains, efficiencies, and improved customer service. Okay, now just a quick background on my company. We're 4PS. We supply Microsoft-based IT and ERP systems. And the key thing for me to pick out of here is the bottom left corner, where we're saying we've installed this system in over 600 different construction businesses over the years, including civil engineering, rail, main contractors, subcontractors, including M&E, house builders and manufacturers, etc. So our company has got a significant amount of experience in this construction sector, and that's why we wanted to present to you guys today. The building blocks of this webinar is going to be fourfold. We want to look generally at technology and what's available today. Then we'll have a look briefly at past and present technologies and the lessons we can learn from them and what we can do with it today. But all this technology is surrounded by data, and that data can be used, and where it's used is a very important way of gaining advantage from that technology. So we're going to be looking at how construction use the inputs and outputs of data. Lastly, we'll be learning a lesson from an industry that has made really good use of this technology, all of the above, and has been doing so for many years. And I think you'll have regard for who they are, and we'll see those later. But what about construction? Let's have a look at technologies in general. We'll not go back too far. But in 1982, the first PC was launched by IBM, which was a worldwide computer giant of the day. That's all there was. You couldn't buy anything else. Mainframes and mini computers, which were as big as mainframes at the time. There was no PC then, but in 1982, the humble but life-changing PC arrived in the world. The reasons it was widely adopted were because it was just the size and power, and like today, there were many apps available for it. Prior to the PC, if you wanted a word processor, you had to buy a dedicated piece of hardware to do the job. We didn't have any spreadsheets, and so the PC brought us VisiCalc and WordStar and other great applications. And the same remains true today, that if a piece of equipment hasn't got a price point, it's usable, hasn't got enough power, and the battery life is poor, then it'll fall out of flavour, which is all about what we do with mobile phones these days. So just looking at how this all accelerated, in 1984 the local area network came into being, the commercial ones anyway. In 1999 the Nintendo Game Boy arrived, and I think we can learn a lot from gaming in the construction industry, from virtual reality and things like visualising BIM. Then in 1990 a world-changing event happened when the internet arrived on our desktops, and the massive amount of information is available from there is just unbelievable. Then in 2001 you can see gaming moving on and the Xbox being launched. But in 2007 Steve Jobs of Apple stood up and announced the iPhone. It was only 13 years ago, and as it took 1 or 2 years to catch on, it's just over 10 years old, that technology. And I bet you've got your personal assistant sitting next to you now, and you're probably reading emails because you're not that interested in what I've got to say. Put it down. But then again, about 10 years ago, the iPad arrived with other popular tablets, and the adoption of tablets happened in 8 or 9 years ago, so the technology has not been around that long either. And now these days we're talking about 5G mobile networks, the super fast capabilities and bandwidth. So the applications there say if you're flying a drone and doing a survey, you're probably writing all that data onto an onboard SD card or something similar. But when it's equipped with 5G bandwidth, the possibilities of sending real-time data directly to your server or network is there. So 5G is a very important current step forward in communications. Okay, so what I want to do now is just have a look at some, not all, of the technology available today that is or can be used in the construction industry. Some things you'll have heard of, but maybe there are things you haven't. The first item on the list is the Internet of Things. Here we've got examples including Fitbit, virtual reality viewers. We've got surveying equipment with GPS and GIS capabilities. At home you might have a Ring doorbell, which is connected by the internet to you and your smartphone, so you can see who's at the door and even talk to them. That's a good use of the Internet of Things. You might have a hive or a Nest to control your central heating. Mine tells me when my home is too hot, over 25 degrees. And perhaps we've got remote monitors and cameras, which is great stuff for people like lone workers and security guards. But you have to look after the welfare of these lone workers these days. It's imperative. And we all know about the capabilities of your car with all its electronics and its ability to communicate. And then we've got augmented and virtual reality. HoloLens, you might have heard of, is an example of that from Microsoft. You've got Microsoft gaming headsets that allow you to visualize yourself in a room fighting the enemy and making the world a safer place for us all. And then we're also able to project into walls the visualizations of BIM and drawings, and look into the breakdown of superstructures, substructures, mechanical and electrical within a building. It's great use of technology. And then today we've got machines. This is a robot called Spot. It's being developed by Boston Dynamics in league with Trimble. And it learns. It's artificial intelligence. It's got detectors and sensors on the machine. And it can learn as you're building stairs in the building. It'll learn it's just got to go upstairs. And also identify spots and locations where it could do surveys to monitor progress. I'll show you a bit more about that in a minute. And robotics. Today we can teach robots to, there's been massive advances in technology. We can teach robots to do a job that a human has been doing, and we can even link it to BIM now. So we can take a walk through a building and visualize the as-built as compared to the design build. And down there at the bottom we've got the evolution of man as it applies to the evolution of robots. Who knows what the future holds in terms of robotics and the like. And then looking at autonomous vehicles and plants, an example of that is if you've ever visited Heathrow car park at Terminal 5, you can get a pod that takes you from the car park through to the terminal. And there are driverless vehicles and taxis now in California. Some keep crashing into each other, as you've heard. And Amazon for many years have had bots running around their warehouse, picking and delivering goods to stations for packing and putting it away. And also we have drones drones, this is a modern use of drones. They've been around for many years, but now because of the reduced weight of batteries and they're lasting longer, and the cameras are a lot smaller, they're actually coming into their own and making a major impact in construction, especially for surveying and progress monitoring. And on the bottom right-hand side, you can see a drone there surveying over mining subsidence. You can't quite see the dotted red grid lines across where the drone has flown up and down. You give you a view this subsidence is happening in a particular area. And that particular one would have taken months to do manually walking around the site. So the drone is producing massive productivity gains there. And then there's exoskeletons, technology that allows workers to work for longer than 2 hours, perhaps 4 hours or 6 hours, without taking the load off them. That's great use of new technology. And then we've got 3D modelling, 3D printing, and again BIM again. Here we've got a picture of a person. We can use the 3D model to model a person for security purposes or replication purposes. Down on the left, you've got BIM again, and we can see that being visualised. On the right, some 3D printing. This particular one's pouring concrete in a building there. You can see it in the middle. It's the largest in the world at the moment, with 640 square metres of concrete were poured under a 3D printed model. And who knows what's to come in the future. So that's a little bit about BIM and 3D modelling. But what about wearables and the like? Well, here we've got an example of a personal distancing system deployed by Interserve, actually. And what it does is alert a person to the fact that they're within a COVID distance of 2 metres of another employee, so helping Interserve maintain their duty to provide COVID separation for their employees. And just last week I saw a new device called a mood monitor. It's a wristband, and the wearer can press it. It will tell you whether he's feeling good, bad or ugly on a particular day, so to help the HR people monitor the state of affairs on people's minds on site. So there's some of the technology we've got available today. All of this technology is either creating or using data and information. In terms of technology and data, we have either inputs that create data or we have outputs that use that data. Let's start with some of the inputs. Here's a very small sample of some of the many inputs that exist today. Here in this diagram, I've used larger variants of older components so that they're magnified so you can see them more clearly. These have all been miniaturized into your mobile phone or tablet, for instance. Up there at the top right is a proximity sensor. You can wave your hand over a mobile phone to change screens and that sort of thing. We've also got on there light sensors and infrared sensors and heat sensors and all sorts of other sensors. For instance, you can log onto your mobile phone these days with a fingerprint or an iris scanner. Well, that same technology you can use on a site gate, biometric scanners for ensure the right people are authorised and certified to be on site at a particular time, for that matter. And we have larger sensors as well that can monitor the flow of water in a dam scheme, things that alert temperatures when they reach a trigger point, or there are critical alerts in nuclear power station. So inputs can come from all sorts of sources. There's another type of input from your laptop, keyed in progress to a Primavera P6 progress application to draw the process of each of the elements of a work breakdown structure within a particular project. That's another input which is feeding data to somewhere. And here's a great example of data inputs. An Airbus A380 is a fly-by-wire vehicle. The sensors of position, height, speed, temperature and that sort of thing are all input through a number of autonomous onboard computers, and the computers vote to what they believe ought to be the next actions. So should we push, pull up, pull down, accelerate, turn, etc. Here's Spot again. This time it's carrying a payload. In this case it's surveying equipment. But Spot can also work as a team and carry goods from goods in onto a position on site for it to be used. They can conduct repetitive surveys, can do safety inspections or take photos of remote locations. I believe they're being used in demolition and mining, where if a blast takes place, you can send a robot in well ahead of time before a human goes in, perhaps saving 24 hours before it's safe to do so otherwise. Another example now, moving on to some more modern stuff, is the use of drones and autonomous vehicles we talked about earlier. Here's an example at the bottom right-hand corner. You can see the vehicle undertaking repetitive tasks in the construction of the A14 in Cambridgeshire. All of these input sensors, hardware and systems are creating data. There's a wide range of targets where that data is sent. Here is some examples of. Let's have a look at one or two of them in a little more detail. A good example, I think, is the building information model. So a good example of data in AutoCAD or whatever, creating digital images of buildings as designed. This is what we call a digital twin. It's a digitized representation of the physical entity. That's why it's called a digital twin. And big data. Big data is technical and relative new science. We've created so much data now from all walks of life. We can't manage it with standard tools. For instance, Facebook has millions of followers, creating millions of transactions per second. And meteorology, where analog, digital, satellite measuring equipment is sending endless, ever-changing information to its computers for modelling. The amount of data being fed into these databases is so enormous you can't manage it with everyday tools and analytics. It requires specialist analytical tools and teams of IT experts to use that data, model it, and then provide timely and practical outputs for us to use. So big data is a big technical issue. Blockchain is something that's been around a while. It's a collaborative concept of distributed transactions, including things like contracts and billing. And it's been introduced into the construction industry relatively slowly. But here we're sharing databases of contracts and billing across on a collaborative basis. There's an excellent paper you can download from the Institution of Civil Engineers website called Blockchain Technology in the Construction Industry, if you want to know more about it in detail. And of course, we've got the World Wide Web and the internet and cloud computing, providing you with all you ever needed to know about everything from growing spring onions to talking to Dr. Google about how to treat your shoulder aches and pains, and everything else besides that you can imagine. Moving on to data and where it is, and it's distributed everywhere. But in data terms, there's also what I call grunt data, which is a little less sexy data. So information you've got stored locally on your laptop or PC, whatever it might be, a spreadsheet or documents or databases. Somewhere in your business, you may have a document store of drawings, work instructions, health and safety documents, compliance documents, all indexed and easy to use on a database stored somewhere in the cloud or on your company network. Then there are corporate systems and applications that are typically a hybrid of best-of-breed systems that have grown up over many years. It's a bit of a hodgepodge in general, but you might have 20 or 30 different systems all trying to talk to each other, and that's what I call the grunt data, finance and procurement and those sorts of things, HR, payroll, the internet, all brought together in one ERP, enterprise resource planning system. But where are we today? Where do we want to move to in the future? On the left is how it looks today. We've got clients, we've got subcontractors and suppliers, all with their own systems, and in some way they might be trying to interact with each other, successfully sometimes and sometimes not so successfully. But the thinking is we should be thinking about a common data model. Here, one common database of things like products and supplier names and those sorts of things. Instead of each business repeating or re-entering data into their different systems with all the errors and repeat handling that goes with it, we should be looking at this thing called the common data model, where we're all sharing one version of the truth, so to speak. So that was all about the inputs and the data analysis. So let's have a look at some examples of how we could use that data via outputs. There are a massive number of ways you could do it. Just use your imagination about how technology and data could be used. It's almost endless. But let's just pick on a few ideas just to illustrate the matter. This little clever little robot here is called a Kibo. It has been taught how to paint walls. So say you're building a hotel and it's got, say, 200 rooms, you teach it how to paint one, and then can repeat the task on all the others. Very efficient, effective use of data learned, and it doesn't rely on personnel who take tea breaks and go sick, etc., etc. And here we have an output, which is the result of the inputs we saw from the Primavera P6 input earlier, and other data within your business. It's a CVR, cost value reconciliation, showing the project work breakdown structure used by commercial managers, commercial directors, the PMs and QSs. Well, they may want to see their budgets and what's been spent and the actuals and what you've accrued against in the forecast and the variance and variation orders and that sort of thing. We're using this as an example of reporting, but that could include outputs from big data warehouses, dashboards and other analytics. All of these are useful outputs from the data in the background source. And then there's a whole host of, we talked about with aircraft being directed by inputs from the autonomous vehicle being directed by job planning systems. And you out in the field, a field service engineer being given jobs to go and dig up the road, lay fibre cables and then reinstate it. Perhaps directing drones to conduct surveys or mining subsidence, or directing the robot to do regular surveys for monitoring work in progress. So you give it some spots on site and you can get it on a weekly or even daily basis to go and review the progress that's been made. And that way you're not using manpower just to walk up and down long stretches of road or rail to see what's happened. So let's move on and draw a comparison with an industry that has harnessed a lot of this technology. You'll certainly be aware of it. It's the automotive industry. So let's compare what's preventing construction companies from harnessing the data and technology like that has been going on for years in the automotive industry, which we all respect and are fascinated by it. By the way, if you have an opportunity, it's really worth going around a busy automated car factory and watching these vehicles being built. It's just fascinating. So let's have a look at some of the things the motor industry is doing. The first is that they've got specific robots that have been trained and taught to pick up materials, change heads to suit the variation of car they're working on, to spot weld and arc weld. They're multi-purpose robots dedicated to a specific range of tasks. And in construction, we're not really adopting any of these techniques. You have seen some examples of what could be doing. Other robots have been taught using their laser scanners and cameras to compare the as-built production model to the design model, and therefore are used for QA and rejecting of models that lie outside of tolerances. And it also gives a good measurement of how productive the production line is being. The production line itself is scheduled by a very, very sophisticated set of production planning systems. They're the back office grunt systems I was talking about earlier. These communicate with the manufacturing processes, but most of all through the supply chain. The BMW Mini, if you go around their factory, they're not producing these cars in batches. Each car in the production line is a unique customer order. So a petrol car will be sitting next to an electric car, an automatic one next to a manual, a red one followed by a blue one, and one variant of another next to the next one. This is a very sophisticated production process. The supply chain is involved in that through an in-depth collaboration with their own manufacturing, distribution and delivery systems, and there are penalties to pay if they don't fulfill their obligations and supply BMW or whoever with the parts, and they have to arrive just in time. So just in time prevails on these sites. There are no storerooms, no warehouses on the manufacturing plant, so the materials delivery lines have just enough stock for, say, 2 hours of running. If they run out, that's it. It's all over, and the machine stops. Construction could learn from this and look at ways of adopting some of this technology by engaging with the supply chain more, for instance. And then in the factory, when the goods arrive, the materials are handed over to autonomous electric vehicles that use ground-guided trucks to route materials to the production station. So nobody has to leave the station to go and get it. It comes to you. And it comes to you just in time, just when you need to fit the electric motor to that vehicle on the production line. We need to learn from this last point in construction. I believe that off-site manufacturing and prefabrication of components and sub-assemblies, wherever possible, can produce massive savings for us all. The manufacture of off-site and deliver just in time to the point of assembly. In automotive, they're doing this with engines and dashboards and seats and suspensions, which arrive ready-made just in time to be placed in the slot in the dashboard, for instance. So why aren't we in construction using technology at the same level of integration? It might actually be true that we're a long way behind in digitisation terms when we compare ourselves to the automotive industry. So here are some of the reasons why, not all, but some. The first is a fundamental one. The car robot is fixed to the ground. The ground comes to the robot. The car comes to the robot. There's no way to do that in a civil engineering or building project. Materials arrive at the stations just in time for the robot to fix or weld, or ready for a human to assemble. In automotive, there are no workers walking around, no toolboxes in the way on the floor. There's no materials or cables lying around in the corner. And it's a protected, clean, shielded environment in automotive, so it lends itself to robotics. This is not the case on a construction site, which isn't fixed. It's a moving, growing target. In constructing a highway, the tarmac has moved down the road. And if you're building a bridge, it grows upwards. And a railway line is very difficult to access sometimes to get goods onto site because of very few flat surfaces for easy access. In construction, you need to learn the environment, which is always well ahead of the specific programming that we've done in automotive. We've got to keep it updated as the project moves along. And it's all machine learning and in artificial intelligence. We're not as advanced yet as we need to be to make an effective tool in the construction sector. But it's not all doom and gloom. We've got robots which are like autonomous vehicles along roads and motorways to distribute materials. We've got robots that plan lane markings and others that remove spoil, repetitive tasks, and they're already in place. And this little fella here, this is an extract from Highways England's website. It was published in January. This mobile robot is a pre-marker for white lines. It was used on an 8-mile stretch of the M6, and it would have taken 2 engineers more than a week to do the job that it did in just 4 hours. Absolutely remarkable. It's being deployed along other long stretches of motorways as well. This is a great use of robots, and we're going to grow and grow the way we use robots in the construction sector, I'm sure. So, what are the takeaways in that comparison of automotive to construction? Well, I think we can see that some of the high tech can assist in many ways on a construction site, but we're not harnessing it yet, in my view. Don't forget to harness the sophisticated systems in the HQ or back office. If you want to keep up with what's going out on site or the delivery of goods that are due or to be planned, and you want materials to arrive on site, and contractors too, so you want the cables to be there at the same time as the electricians. So it all needs bringing together. And to advance this integration, you need to involve the supply chain. It needs to be heavily involved in achieving your goals of efficiency, capacity, time saving, manpower, labour costs, etc., etc. So it's not just an internal process, which means sharing your data and your processes, successes and productivity with your suppliers and your subcontractors. Share your dreams, share your goals. The result in automotive is just-in-time materials, which you can see if we could achieve something along that lines of great benefits. And the auto handling of plant and materials on site, we need to be thinking about doing this now. It's perfectly possible. The technology is there, and you can see the use of it is beginning to grow. And I think this is something that manufacturing off-site and prefabricating components of build and modular buildings, etc., we need to think more and more about doing that and saving costs and saving time and having them delivered just in time so that it doesn't clutter up the site with large pieces of building materials. You need to help advance this. One of the things you need to do is embroil the fund holders so that there needs a significant investment if you're going down this route. But the return on investment needs to be defined, it needs to be clear So the costs associated with it and traded off against the investment required needs to be very, very carefully planned. And if you're looking at efficiencies, how do you measure those? It's very difficult, but you need to be clear about what they are if that's the intention. And the plant's work site capacity will be increased if you've got more efficient use of labour and materials arriving. And indeed, as a consequence of that, the customer service will be increased and your clients will be happier. And this is all utopia for construction to adopt these advances. We're at the leading cutting edge of technology today, and we need to further its use in construction by deploying it, by costing it in, and by investing in it. So what are the obstacles to digitising in construction companies? From collecting data and storing it, aggregating it and analysing it. Well, somebody needs to get down to defining and quantifying the benefits that could accrue from this technology using the data that you can bring in. And there aren't very many people around that can do that. It's a specialist area. This project needs top-down support from your board of directors. At least a big initiative to be taken on board and dedicated and experienced staff that need to be brought in. There needs to be a significant overall budget allocated to it and a commitment to use it, which can be difficult sometimes as margins in our sector can be slim, and just to justify even countenance the expenditure can be tricky sometimes. So the return on investment needs to, what's the goal? What's the target? Is it financial? Is it profitability, productivity, or workflow? A reduction in labour or manpower? What is it? That needs to be defined. Once it's defined, it's a no-brainer because the return is so significant. As we said all along here, will clients, suppliers, subcontractors join forces in the supply chain? If so, how are they going to collaborate and bring about this change? Do you have the buy-in of busy people? The people that would oil this project would be the people that are the busiest in the business. They're the cores of the cogs that go round and round. And these people need to be on these projects. They may see technology as a nuisance and a diversion from their day job, so to speak. But to a large extent, the technologies in place are PCs, laptops, smartphones, communications networks, the internet, specialist devices. The infrastructure is there to start harnessing some of this, but maybe we don't do it as best as we could be. So what's stopping us embracing this and collaborating? Well, sometimes it's just not my job. I'm doing my job well, and I'm well regarded, and I don't need to get involved in any of these sideline projects where it's not a sideline project. Sometimes there's a fear. The fear might be a corporate fear, whatever level within the business. I don't mean an individual, but the business may not have the technical capabilities in IT particularly, and IT projects of this nature can be a bit scary for some. And can be seen as just a cost and without a return on investment, which is why it's so important to identify the goal and quantify it. And what about all these islands of information? Local data stored on PCs. You need to embrace all of this. They need to bring in your corporate systems, your document store, and the grunt systems like HR and procurement and finance. And then it needs to be shared and exchanged in an open, collaborative way. So that's it, ladies and gentlemen. We'll go back to the beginning, the objectives of this webinar. Well, I hope you found it interesting. It's certainly non-technical, largely COVID-free, but it gives you a feel for how fast technology is moving, and identifying the past. And it clearly illustrates that we're moving in a very fast-moving environment, and keeping up is very important. So the speed of it is just amazing. We didn't realise how big the databases are, and how many data sources are input into those databases, generating absolutely masses of information. And what technologies have we got available to use that? Well, we talked about big data and about analytics and that sort of thing. The internet and mobile networks, they influence what we do every day, and they're growing and developing and everything. We've now got WhatsApp and Snapchat and all of these sorts of things. We've got Fitbit and wearables. They're all moving on very quickly. They're all new. They're all moving quickly. And what will happen in the future? So digitisation. we're at the cutting edge of it. We can embrace that like automotive has. There's a lot we can do with what we've got already. So what's holding you up? What's holding you up is identifying that return on investment. What's the project about? And you need specialists to do that. Trying to do it from scratch is going to be tricky. So have a look around and find some consultants or recruit some people who have got the right level of skill and experience. And in the end, you'll end up paperless. We've been trying to go paperless for donkey's years. I remember going back when I first wrote my program in 1970, we were still trying to go paperless then. But we're striving to reach that. But I think we can. You can see a lot of this digitisation and the digital twin that gets rid of all those paper-based communications. So that's what this was about, bringing it all together in construction. So I hope you found it interesting. And if you want to get in touch with me, here are my details on this next screen. My email address is paulb@4ps.co.uk. And my telephone number's there if you want to give me a call. So thank you, ladies and gentlemen, and goodbye for now.